Hello, everyone. Welcome to JRush episode 6. So happy you're here. I'll give you some time to catch up with the stream. And while you're catching up, I'll quickly introduce what we have here. Today, we have three amazing speakers. They all will tell you things related to security. Security is very important. It's trying to shift left, at least for last 5 years, and hopefully will help it to be shifted slightly. Today's talks are not exactly bite-sized, but they're close to that. They will be around 25 to 30 minutes each. If you have any questions, do not hesitate to ask them in wherever you find appropriate. The most comfortable place to ask them is obviously in YouTube. To some of them, we'll answer after the talk. With some of them, who knows, maybe I'll jump in and ask them in while we are live. Anyways, I am Pasha Finkelstein, and let me introduce our first speaker, Patrick Baumgartner. Hi, Patrick.
Hey, Pasha.
How's
Nice to meet you.
Yeah, nice to meet you again. Are you scared?
Sorry, you were scared?
No, are you scared?
No, not at all. I mean,
Yeah,
so I'm happy and actually, I'm prepared for the session. So I'm looking forward and give something I prepared, especially for JRush. So yeah.
Amazing. Then I won't introduce you. You can probably do it yourself perfectly. Let me turn on your presentation, and it's here, and remove myself from the stream. You have a stage.
Thank you very much, Pasha. So I'm going to talk about build packs, and we will also see how you can hack your own build pack, for example, with a feature which does not exist yet in build packs, but it's pretty new in Java 24 and 25 added. So I think that will be very interesting to see how you can do such a thing yourself. So yes, shortly about me and myself. I'm Patrick. I'm from Switzerland. I'm very much involved in the software development community in Switzerland. I'm organizing events, as you can see. I also recently became a Java champion, so which is kind of a nice reward. And I usually work with customers, with their teams to produce better software and also delivering faster. And of course, my goal is actually to work with humans on code or software solutions for humans. So what are we going to look at? So we'll have shorter look at build packs, because or even containers at the beginning, and then we dive into build packs, because I think build packs is a very nice topic, and you will realize that Docker files usually have some issues attached, and usually it's that software developers do not have the capacity in the brain to do everything from developing software, doing security, doing testing, doing cloud, doing everything else, right? And that's what we are going to see. And then afterwards, we will have our own build pack. We write our own build pack, or at least I try to demo it in a way so I can show something to you. And of course, we are going to see also something regarding AOD caching. And in the end, we'll go and summarize the whole thing. So we all know what containers are actually, and also how they are layered, and also how Linux is going to separate this kind of running containers from the host operating system. So I don't think I need to dive too much into the topic, but I'm pretty sure you know many things already. So that's containers. And a good friend of mine, probably you know him, he said once, friends, don't let friends write Docker files, because there is so many strings attached to Docker files, and there is so much ways to actually create containers. So I really like Josh Long's quote on this, because I believe the same. I think software developers should not write Docker files themselves. But you will actually see why there are better ways and how there are better ways to do that. So the solution actually in the end is to use cloud native build packs. And cloud native build packs are a thing. They are a CNCF specification with tools how to create basically like your containers. It's like one tool where you can run and there will be automatically some detections going on to do certain things, do like creating layers inside your container for a particular topic. So build packs are already there for quite a while. And as you can see, basically, like it started from Heroku. Then actually, like when Cloud Foundry was a thing, there was like build packs version 2, and also like Heroku adapted. And then in the end, actually, like cloud native build packs became a standard with this buildpacks.io specification and being part of a CNCF as a project. So I think that's actually like quite an achievement. And that means also like there is a huge community around this to create containers with build packs. So Paketo is basically like the best implementation for build packs, because like the tooling available and also like ways, and we will go and see like later a bit deeper how containers are created, are the best with Paketo. And that means like there is so many features out there. And if you're, for example, a Spring developer, your Spring Boot will actually use Paketo build packs under the hood. And we're going to see also like later how this is going to look like. So Paketo has like one big advantage, because it's not only like for one technology, but it's like for many technology, as you can see. And the goal is actually like to create containers in the same fashion for all the different programming languages and all these different stacks. So that means not that you need to write different Docker files or different ways of Docker files how to achieve the same goal. So for example, if you would do something like adding certificates to a container because you need to, because you're running like in an enterprise environment or so, then actually like it doesn't matter how you do it for each and individual platform. It's always the same approach with build packs. If you write your Docker file, your Docker files might look very, very different. So like they use a consistent approach to create containers. So cloud native build packs are actually like really relevant these days, because like there are many topics which are really important behind that. So that means like cloud native build packs simplify the way we build containers these days without the Docker files. So that means it's simpler. It means also like that we can have across different teams, across different environments, across different stacks, the same approach, as I said already also before. And then actually, like if you look from a security perspective, it's also like the best thing you can have, because like the build packs, but also like the run images and the build images, they're like updated all the time. That means like you don't need to care. You can actually like leverage this from the community. And another nice advantage is actually like that if you run your container generation in build pipeline, build packs allow to cache layers, and also that accelerates the build, but also we can create reproducible builds that are very important these days, because you want to make sure that the software you get as sources are like the same as you get as binary by building it yourself, and you can like reproduce binary compatible containers basically. Right. And then there are like other tools, we'll see that a little bit later, which actually also like are nicely fit into a modern DevOps workflow. So build packs are basically like adopted everywhere. If you think like from container platforms, from PaaS platforms, you can run it basically like everywhere. You have like tools in the CI/CD space. I'm not going to name that because that could be just like your common like CI/CD tool. But then also like if you think of like your Spring Boot, there is a Maven and a Gradle plugin. If you think of Quarkus, there is the same. There are even like command line tools. And there is like plenty of things out there you can use directly. Build packs create OCI compatible images. That means like you can run it on a Docker like runtime or containerd, for example. And as well, also like container registry have adopted to build packs as well. Because if you know that you could see like how the layers are created, for example, on Docker Hub, from a Docker file, you would also see like how the layers and what kind of layers were created by the build packs inside these container registries. So that option is there like everywhere, and we just can use it like a regular tool. So build packs actually like consist of like three things which are important. There is like first the specification, which is actually a Git repo on the cloud native build pack organization in GitHub. Then there is the lifecycle library, which defines like how the lifecycle is executed. And there is the pack CLI tool, which actually helps you to run the whole thing from the command line. And of course, if you use something like Spring Boot or so, your Maven and Gradle plugin will take care instead of the CLI tool and will run the lifecycle from there, basically. So why should you use build packs instead of Docker files? If you look just like at this simple example of a Docker file, which I copied from the internet, it contains so many flaws. And just because I didn't know better, and of course I do, I just like copied some lines which are not really nice, because like there is the thing that, for example, if you inherit basically from the OpenJDK, you will realize that thing is outdated and it has lots of vulnerabilities. It's not maintained anymore. So that base image actually like you should not use at all. If you copy the fetch jar from your Spring Boot application, that's not best practice, because if you explode your Spring Boot app, and that means like you run it in an exploded way, it will actually start faster. And that means also like we can create smaller layers, which also allows us actually like to have like faster shipment of the container to the worker instance, for example. So we get like smaller layers. And that means also like caching layers can be done like in an easier way. If you think of like running the whole application here, just like with Java -jar, there is another flaw involved here, because you probably are going to use a privileged user, which is a bad idea. And that means like if you look at this example, there are so many issues actually like using just Docker files, right? So yeah, you should not. Below, I have linked a very nice blog post from Snick, which I usually reference all the time, because like this blog post actually like explains 10 good practices how to create a nice node container. And of course, it applies directly to your Java application as well. If you think of like how build packs are doing it, you will find like all the suggestions made there, they are done in build packs too. So have a read on the blog post. It's a little bit older, but I still like it a lot, because it gives me an insight like what should I do better. So now actually like if you think of a Spring Boot application and with build packs, you will get something when you start your container from scratch, you will get something like this. And what is not typical, what you rarely will see, is basically like the part here, if you run your Spring Boot application from your IDE. If you look at the lines here, we have something called the memory calculator, which just like tries to do the heap calculation, how to like size the heap properly for your JVM, according to the resources which are passed to the container. So that means like this time I give it like one CPU, the next time I give it two CPUs, and also like different size of RAM. And the sizing of the CPU, or basically the heap, sorry, is done during the runtime, the start of your application, which is quite nice. And then if you look into the other Java tool options mentioned here, there are other things which are just added. It's, for example, exit on out of memory error. You will see like some Spring Cloud bindings added there for liveness and readiness probes, and so on and so forth. And if you look a little bit deeper into the whole thing, you will actually like realize here it's not running with a privileged user, right? So that's quite nice. And you see already like the whole thing actually like works way better with build packs, because you do not need to think of this. Maybe you have realized this application is built with Spring Boot, the current release candidate. So that also like my demo is using like the newest, shiniest pack clinic with the RC2 from Spring Boot. And as we know, by the end of the week, like Spring Boot 4 will be released. Now let's talk shortly about the architecture of the build packs and like how they consist of different things. So imagine if you're doing a build, you need a build image. The build image contains like all the tools to actually like build your application. And then on the other hand, there is a thing called the run image. And the run image actually like is used to run the whole thing. And if you look further, you will actually like realize there is like build packs which are doing certain things. And then there is also like the life cycle, which is orchestrating the build. Sorry, I'm a little bit confused because it looks like my image is like stuck. I'm not sure if you hear me. So maybe you can write something into the chat.
We do hear you, Patrick. We can't see you, but we can
you
hear
me. Perfect. Great.
Yes.
Thanks for mentioning. Let's hope the image is coming back. So the life cycle actually like is going like through several phases. And then we have like the builder, which combines like everything of the things above. So that means like build image, the run image, the build packs, and also the life cycle, right? So these are the most important things. So if you look at the whole thing, that means like we have source code on the, let's say, left side, and we want to transform the source code with build packs into a container image. So the build pack itself, or there are probably like multiple of them, they're basically like transforming the container or the run image, and they're just like adding additional layers on top. So yes. So there is also some metadata involved, and this is basically like part of the build pack TOML file. So we will see that in a second. Good. So if we're talking about the life cycle, you will actually like realize the life cycle consists of different phases. So there is the analyze phase where the metadata is basically like checked, and like we try then afterwards to see if there is data available from previous builds. So we can like restore things. That's the idea. We are going to check if things are restorable. Then there is a detect phase where the build pack is going to check if the build pack actually like needs to run. And the third one is actually like the restore phase. So if there is a layer which is cached, can be like restored. And then if it cannot be restored, we need to build that layer in the build phase. And in the end, everything is exported as a container. So this is basically like the big picture. So we have the builder, which consists of different build packs, but it consists also like of the run image and the build image. And you can provide those things either like as one builder, which contains everything, or like with different pieces, which are basically just like containers as well. So depending on what you want and how you want them, you can usually like get them as individual containers or like as a full container in the end. So that's like why sometimes the builder is actually like quite big, and that's usually like 1.5 gigabytes or so. But don't worry about that. There's just like everything in there, so that's why it's so big actually. Now, if you think of like having a standardized approach, there are definitely like many reasons why you want to customize your build packs or even like reusing certain build packs. And the one thing could be like that you want to go like with a specific version of Java from a different vendor. Or maybe you need to add, for example, like CA certificates because like your company has its own certificate registry, and you're basically like doing it on your own. Then actually like you might have also proxies and other things you want to do, right? So there are probably like many reasons why you want to have a build pack. And fun fact, I did it once because it was needed. I had to add in a way like a custom font to the container, because if you think of like marketing wants to have reports with a special font, which is not part of the container, and you render the PDF like inside your container, then you need to add the font there. Good. So then actually like the other thing is there is a nice command which only like works for build packs or for containers built with build packs. It's this pack rebase command. And you can imagine your container has the run image on the most lower layer. And with pack rebase, you just can like replace that. So for example, you do not need to rebuild your whole application. You just change like the run image, the base image basically. And you just can replace it because you need to maybe move fast and like replace the run image because it contains some vulnerabilities. And if you want to see, like there is also a registry for build packs, and you will find like hundreds of different build packs there. So let's go to the next one. So yes, Paketo actually, as I said, is basically like the biggest player because they have like many things compared to all the others. So you might have build packs from Google, you might have build packs from Heroku and so on, but Paketo is very nice actually also like for Java. Paketo provides us like different run images in different sizes with different functionality. And you can also see it's not only for Java, it's for many different programming languages. And they also provide us like tools, for example, to add additional certificates. They add, for example, SIFT for SBOM generation. So you know like what you have installed in the container, but also like which jars you have inside your container for your application and things like that. And they add also like labels needed actually like for the container image. And of course, for developers, it's quite nice since a few months, or basically like since the last version or the previous last version of Spring Boot, we have like ARM64 support. And there is even like if you need to deploy on OpenShift and you're forced to use like UB8 or UB9 as a base image, they even provide that one. Of course, like if you think of the Paketo build packs in the Java field, there is like many things out there. So for example, you could like install a Tomcat if you want to have a ward deployed inside there. You can have like agents added if you need things and so on. And usually you're just using like environment variables for the build pack run to like specify certain things. And we are going to see that also later. Then actually, like if you think of like build packs inside your Maven POM file, you just can name the ones which one you want to use. And here I just like was specifying one from Oracle because by default the one from Bellsoft will be used. So I just wanted to show you can actually like switch which Java distribution you want to use, and you can even add your own ones if you like. And of course, the Spring Boot build pack is quite fancy because it allows you to do some things like, for example, app CDS. It allows you to add like the Spring Cloud bindings. It adds the memory calculator. It does like many other things. And that means like this is quite powerful too. If you think of the Java build pack and you want to use JLink to do a customized JVM, that's actually also possible. And even there is like native image and GraalVM support, right? Great. So let's dive shortly into demo. And I want to shortly show you how like such a run with a build pack is going to be executed. And therefore, I just like jump into my Visual Studio Code because I have things like added. And I want to show you here, this is just like my pet clinic. And that's my Spring Boot Maven plugin. And you will see here, I'm just like relate to the build packs from Paketo, so the Java build pack. Actually, like that one would not be needed for the demo right now. And I add even my own one. My own build pack, that's a simple one actually, is done like this. So that's my ASCII weather one. And I even tweeted about that today because like I found it like funny. because I had very cold weather, and it said something like, it's perfect time to refactor. So we have learned already that there is a detect phase in the build pack. And my build pack here, it's just like participate always. I do some logout and I just say, I will actually like work all the time. And then in the build script, and this is just pretty a bash script, as you can see, but build packs typically are done with Go. So you have just like executables with the same name, and you can do anything in here. And for the sake of the demo, I just like went to the openmeteo.com API and was fetching the weather and was like doing some funny thing to like get the weather of today. I mean, sometimes you need to have like some funny thing inside your build, so it's not that like boring when you need to watch your build. So this is like the thing. And if you look again into the POM, I'm just referencing the folder where I have stored my build pack, basically here. And if I'm going to execute now my build, you will actually like see that the whole thing is running, and will take a minute. And probably I'm going to restart my camera right now. Let's see if that is possible. So I'm just using like the different camera, so that works now for sure.
Now it works.
Yeah, that's the different one. So we don't care. So while the build is actually like running, you saw that the build was running without a test, and actually here the whole thing starts for the build pack. And what we can see here is like the detection happened, and even my build pack actually like got added to the whole like life cycle. And now when we run through, you see like many things are actually like done. And there is a thing actually like executed, which is called the ASCII weather forecast, which now does some call out to find out like what's the weather in my location. And it says something funny actually here. And yeah, we are like in an overall good mood, right? Freezing, but we don't care. It's just continue to build here, right? And then actually like, because that was the last one in the queue, you will see that the whole thing created now my container. And I definitely like could now run my container from here. So that means like if I do something like Docker run, I usually use IT because then I have like nice pretty printing and like colors in the console, as you can see now. Then your Spring Boot application is starting. So it's just like working as expected. So nothing special, right? A very simple thing, detect phase, and then I do something like more sophisticated inside the build part. So I'm jumping now back to my presentation because I want to introduce you to the AOT caching feature. So what we want to do is we want to like speed up the whole like start of our application. And there is a new feature introduced in Java 24, which is kind of like a part of Project Layden, and 25 made it even like nicer. So the idea is we would love to actually like start our application, and we would dump the classes which are already read, parsed, loaded, and linked into the IoT cache. That means like in a subsequent run, we can just like use the same thing and start up faster. We don't have to do it again. So that means like it's way nicer this way, right? So AOT cache and kind of like app CDS is kind of related. So if you are like in a newer environment with Java 24 or 25, you should definitely use like AOT cache over app CDS. And that's also the recommendation from the Spring team. And don't worry, it does not hurt. If a class is not found in your cache, it will just like load the classes from the jar files anyway, or like from your class files from the class path. So that means like it's a no-brainer to add this functionality to your containers. Now, what or how would that look like? So in Java 25, they added a flag which does basically like the record and the create of the AOT cache, which is just like this AOT cache output we need to provide. And the thing above is just some additional logging. And we could use a feature they have used also before for app CDS, which is called the Spring Context Exit on Refresh. So that means like the Spring Boot application is stopping when actually the application is fully started and the beans are initialized. And like when we stop, the cache is written, right? So that's actually like the goal. We start the application to a certain point when all Spring Beans are initialized, and then we stop, and then actually like everything is stored to the AOT cache file. And of course, actually like when you start your application afterwards, you would provide the AOT file at runtime, and that means like it's running faster, right? So it's using those to load and additionally the others. Be aware of if you use like things like use compact object headers and so on, only at runtime, for example, the AOT cache will be ignored. So like there are several headers you would have to use during the training run, like on the run, on the regular run, right? So if they are like incompatible and like the way the objects are stored in the cache is incompatible, it will just ignore the cache and it will use the same startup time without the cache. So what you're going to do afterwards is we are trying to see like how that works in the detect phase and in the build phase, of course. And we keep in mind, and I have additionally an example where we can do the whole thing also with like reuse or caching, with reusing the cached layer. But I think that's too much, but I will provide you the sources to that so you can have a look at these things yourself. Anyhow, let's actually like jump into the next example. I want to show you here in the POM file. My goal is actually like to use the AOT simple caching build pack. And that's why I just like enable this one. I just keep like the one actually like for Java and add my own one. And we will have a look at like how this whole thing looks like. So let's first have a look at the build pack TOML file, which is kind of like the meta description. So what I described here is basically like an ID, a name, and things like that. And then you'll see also like stacks, which is usually used if you like specify like some Ubuntu, or like if you have a specific distribution of your base images you're using. Then you see also like targets. I think it should work like for all of them, like ARM and AMD 64, right? This is just like meta description. In the build pack TOML, that's just like a thing you need while building the whole thing as a container. So that's not needed at the moment. And then we can have a look at the detect phase. And in the detect phase, basically like I'm not checking anything to be done. What I just make sure is that we depend on the build pack which creates the JRE here. So we say like we depend on the Java build pack. So Java needs to be there that ours can run, right? So if we dive into the whole thing here, then we can see in the script, there is some scripting, as you can see, and also like making things a little bit nicer. We'll see that we are basically like creating a layer. So like every build pack usually creates a layer. And that means like you need to create a directory for this. We are running now because Spring Boot app will be already like exploded in there. We are running it like the container run our Spring Boot application. And that's why we would use the jar launcher. And you see things like the cache output and also the on refresh thingy. And also some additional logging because it's just fun to see like that there is something going on, right? Then we also like specify certain things like when the layer is like provided, maybe also like for other build packs. And that's like where I said like, I don't care. This layer is not needed by any other build packs. So that's why I disable them, even like for caching. Because I would have to calculate in a way a hash or so to make sure that I can like reuse a layer. So that's why I don't do it here. And a very important thing is basically like I need to add this AOT cache parameter to provide the AOT file. And this is actually like added to the Java tool options. And this is just like a very specific way where you need to write things into files so that it get picked up automatically. So yes, that's not such a big deal. And like when I'm going to run the whole thing again, I just like run it again, and basically like as a parameter you see like I specified name and also say like clean cache equals true just to make sure we don't have caching problems. If I now rerun that, you will see like a few things. So the whole thing is starting, of course, and now it tries to build the whole thing, and like all the things are fine so far. It installs like Java, and you will actually like realize my weather thing is running, and then actually like the training run is executed. So my build pack for the AOT cache is executed. So that means like my Spring Boot application is starting, and now you see some AOT things going on. And it just like loads all the classes, and in the end, when I scroll a little bit more down, in the end, it will dump it into the AOT file. You see there is an intermediate step, but actually like it dumped it into the AOT file. And of course, now it's creating the container. And if we just like restart the container again, you will actually like realize here in the parameters we add, we have this now parameter added for the AOT cache. And actually like your application starts up faster, or at least it should, right? So yes, it's about like 2 seconds. So now let's jump back to the presentation and let's finishing the whole thing up. That's the thing actually like where I wanted to show you a few things, because I did some benchmarking. I like benchmarks quite a lot. So I wanted to find out like if I built my pet clinic, for example, without AOT cache and with AOT cache, how the different looks like. And if I use like the default builder from Paketo, which contains like an Ubuntu Noble in a tiny version, you see basically like the size of the container like grew by 23%. Of course, it's about 112 megabytes of like AOT cache, which is inside additionally in the container. But what you can see is if you use like Belsoft Alpaquita in the glibc or in the Muscle version, which are definitely like smaller, and they are very small, like the base image and also the Java distribution, you will see like the increased size is bigger because like the relation is slightly different. But I think that doesn't matter. The thing here is just like we are even smaller with the Belsoft Alpaquita base images provided by their builder. What is even more interesting actually is that if you think of like running your application or starting your application from scratch without AOT cache and with AOT cache, you're about like 1/3 faster. So that's like the measurements you can see like with one CPU. That's the measurement like with 2 CPUs. And if you know me, I always say like it's probably best to run your Java application like with 4 CPUs. That looks like this. So it's getting even better, but it's like roughly 1/3 of time you can save during the startup of your application. The runtime behavior should not change because it's still like the same things going on. So that means like there will be some optimization with the JIT and so on. So it should be like just like your regular Spring Boot application behavior. Great. So if you want to provide me feedback or maybe you have some other ideas I could do, please let me know. I was just like want to provide you some key takeaways, and that's my last slide. You will see or you saw that actually like using build packs, it's so much easier than writing Docker files. And you don't need to do that. You don't need to be a specialist in infrastructure to do Docker files correctly, because there are so many issues with that, or could be at least, and you don't know like all the traps. And if there are features not out there, like for example, the new AOT caching in the build packs, it's actually quite easy to do it on your own. And of course, you can actually like choose like your own builders. So you have like different base images, but also you can choose like different JDKs or JREs. And yeah, so I think actually like it's quite a nice tool, and you can really like streamline the whole thing, how you create containers for your team. So if you want to have the slides and also like the examples, head over to my GitHub repository and you can download all the things there, and they should be executable.
Thank you so much, Patrick. It was amazing. I'm actually amazed how simple it is to create a new build pack or build pack layer or builder, probably the correct way to say it. We have an interesting question in our chat though. How do you think, for those who don't have extensive knowledge, would you recommend creating your own build pack image or using a pre-built ones from a vendor? Like, should you
I
create
mean,
new builders?
of course, I would use a build from a vendor. For example, the default one which Spring Boot uses for Paketo, but also like the one Belsoft provides, because Belsoft uses like Alpaquita underneath, and they have like base images which should not have vulnerabilities in there. I hope we're going to learn today a bit more about that later. But also like the Ubuntu ones, they're usually patched quite often. So I would not do the hassle and do the things on my own. I would like base on things like others did already, and then I'm so much faster. The reason why I did my build pack, the ASCII one, but also the AOT one, with Bash scripts was just because I can. I'm a Java developer and I'm not able to write Go code, and I don't want to learn Go for that purpose. So I thought it's easier just like to script it in a way, and you can basically like do it as you like. And fun fact, actually, the version you saw like for the ASCII weather build pack, which creates this nice output, if I would use the Belsoft builder, they don't have curl in there. So I cannot actually like call the API from outside to like fetch the weather information and do some nice printing. So you will actually like realize if you play around with that, I added some fallbacks. So yeah, but this is
That's
just
nice,
like
man.
when you play around with those things, you will see like small differences. But even though I've been playing around with different builders already like for more than 2 years, and the one from Belsoft actually are quite nice if you are not allowed to use Ubuntu, for example, in production, because Alpine is usually like thinner, but it has like a disadvantage depending on the distribution you use, because like if you use the muscle based Alpine Linux, you need to use a different JDK distribution, right? You need to use a different build, and the glibc one, which is also like in the Belsoft, you can actually choose like from both. That's also like the one you would get from Paketo by default. It's just like usually also a little bit bigger than the others. So it really like depends like what you want.
Thank you so much, Patrick. It was very interesting. We are slightly over time, so I will not ask you more questions for now. If you will have time after, if you are willing to stay here, I will happily ask them after.
Sure.
But for now, I will pass the word to Grigory. Patrick, I am saying bye to you temporary. And hi, Grigory. How
Hi,
is going?
hi, Pasha.
Oh, I should probably hide Patrick's slides too. And do you want to introduce yourself, or will you do it during the presentation?
I will do it during the presentation. Please
Oh,
share my
okay,
slide.
beautiful. Then, without further ado, I am sharing the screen of Grigory. Good luck.
Thank you. Hi, all. Thank you for joining me today. My name is Grigori. I'm working in the security team at JetBrains. I'm a security tooling team lead at JetBrains. Today, we'll discuss how our IDE, IntelliJ IDEA in particular, could help you make your products more secure. But before we'll start, I was thinking about the shortest security recap possible, and I came up to idea that should be only one slide. The whole idea for the application security and security in general: do not trust strangers. Like, never take candy from strangers. You probably heard this phrase from your parents, and you may now translate it to your children. Yeah, like in real life, in application vulnerability occurs when untrusted input, like also could be called source, reaches an unsafe output, or called sink, without escaping or validation, also could be called sanitizer. It's the whole idea behind taint analysis, if you ever heard about this. It's kind of important slide because we will focus on taint analysis and taint analysis like vulnerabilities during the demo. One of the shortest possible examples here on the slide. If you have something like a user input somewhere in your URL parameters, here it's called age, and you translate it back to user without escaping or validation, then you have a deflected cross-site scripting vulnerability. There could be other kind of injections, SQL injections, past traversals, but all the rejections are based on the idea that you somehow decided to trust strangers. Okay, it's enough for the recap. And it's shortly about the setup of the demo. I'm using the latest available EAP for IntelliJ IDEA from November 5. I'm using Cardano plugin, security analysis plugin, and WebGoat project. If you never tried this, it's a good project to start learning application security. It's in Java, and it's a nice place to take a look on vulnerabilities in code and try to exploit them in a safe environment. But today we'll skip exploiting at all. We'll just focusing on a demo inside the IDE. So it's demo time. Okay, it's IntelliJ IDEA, right? And we're going to start with the first thing that we'll do is our new package for the demo inside this WebGoat application, because we'll try to start with something really simple. It will be a Java class called hard-coded secrets. I will use it later. Let's ask our AI assistant to generate something like some fields with random hard-coded secrets. Let's wait for a while. We will use this example to trying to read the simplest inspection possible, and we'll do it really quick. So, okay, we have enabled inspection. Let's open our default configuration and copy it to a new one. We'll call it demo security. Yes, and we'll disable all the inspections to not have other disturbing highlighting. It's time to close the project from the side. Okay, so we have some hard-coded secrets in our test file. How we can find them? My suggestion for the beginning, obviously you know about the inspections that you can pack inside the plugins and install inside the IDE, but there is a simple approach. It's called structure search. You can use it. If you have never heard about the structure search feature, it's really nice. It could find code not just by the text itself, but according to the name, using the structure of the code. So we have something like a class, and we have fields inside it. So we'll start developing our structure search pattern for catching these cases. So first of all, it is a class, and there is something like a fields inside it. And the class name could be anything. So I'll rename it to wrap it as a meta variable. We don't care about the modifier for this. We also don't care about this one. We'll focus on token, and there it could be anything that looks like a secret. And we'll focus on matching secrets only. Okay, so we have a find here for the secret structure, but other points that there could be things like patterns for the secrets, right? So we have something like prefix. Let's focus on something like this one, and we can add a modifier for the secret itself. It could be done via text modifier, and you'll have something like a prefix, and then could be anything. So now we're focusing only on one particular pattern. It looks like a GitHub token, and we can find all these problems inside our code. There could be other text patterns like Amazon. Looks like it is AKA. It could be something like, I don't know. Let's stop with this two. Yeah, okay, makes sense. So we have 1 and 2. We can save it, and we can save template as an inspection, and it will be work like a hard-coded secrets. Let's call it demo hard-coded secrets. Okay, so it is working. We have it here. We can find our results, and we have an inspection here in a predefined structure search. It's called demo hard-coded secrets. We'll enable it. We have one template here, and we can find results. Well, it's working. Okay, but defining patterns for all the possible cases could be tedious, and it's only like one case. You can use structure search for many other cases in your code. But what if I would like to do it in a more intelligent way, let's say this way? So all secrets, compared to other constant strings, have a unique quality. They kind of random. It's the whole idea behind these tokens and secrets that should be something that is not easy to guess usually. So let's try to build something based on this knowledge. We'll create a new directory here, and we'll call it inspections. It's a special name for the directory. You should call it in this particular way, because only then you'll have this custom inspection field. It will be a Java local inspection template, and we'll call it demo hard coded secrets. Okay, so now we have a lot of comments and code for the template. We'll close it and remove all of this just to focus on the important part. And what do we have inside this inspection? So this inspection is, should highlight every local variable in method inspection. Okay, let's recompile it. Go back and try that it is working. Let's add something like a method. And I don't know, let's add something like, yeah, so it is highlighting by our flexible inspection. Okay, it's time to go back and deploy the code. But if I don't know what is the structure, and this inspection, if you ever try to build other inspections for our IDE, based on the PSI structure, and PSI is our way for working with the abstract syntax tree for the programming languages. But if I don't know the structure, how can I guess it? It could be difficult, but there is a special tool designed to help you. It's called PSI Viewer. And for this, you should go to our project, navigate to our code for the demo. It's hard-coded secrets. So here we have PSI tree with all the elements for the PSI, and we see that the class is a PSI class, and inside it we have PSI fields. This one, the whole structure is a PSI field, and inside PSI field we have modifier like public, private, the word. We have type element, in this case is string, and we have a literal expression. And this literal expression is what we are going to analyze. Okay, let's rename it to something like hard-coded secrets. For every class, we should go and find all PSI fields. It should be not that difficult, I believe. So we have a Java class. Instead of methods, we'll find children of type is a PSI field, I think. Let's import it.
It's
And
PSI
for-
simple, isn't it?
It's PSI field for the fields, yeah.
Okay.
So we should find all the fields. And let's show something like a message for this, just to debug our approach to this test. And we are going to call it field. And there will be a field here. Okay. Just give me a second. So for Java class, we should find, yeah, let's copy a bit. Yeah, I'm not that good at a live demo. Let's copy this place. So we have for all the classes, we should have PSI fields. And then we are, okay, let's do it a different way. I'll copy the whole place and we'll try to explain it because, well, it's a live demo after all. Okay, let's try to figure out what is going on except for this place. So we are going for the whole classes. There could be many classes in the one PSI file. We are finding PSI field. It should be a type of a string, and then it should be a PSI literal expression. And for every variable, let's try to highlight it. So it should be, let's set it to 0. Okay, let's compile it. And we should enable it, I believe. Yeah, it's hard-coded secrets. It is here. Analysis is successful. Let's check it in a different way if we have it here. Otherwise, we'll just go to a different place, to a different part of the presentation. Yep, it's enabled. Okay. So I will copy the whole code, maybe. I mistyped something. Yeah, and I'll copy the function for calculating the entropy. Okay. There should be one mistake somewhere. Let's find it. It should be, yeah. This one. Okay, one. Oh, okay, now it's working. Sorry guys, it's like, folks, it's a demo. Okay, so we have a method that we're finding all the PSI class. For PSI class, we are finding fields, and for the fields, we define the type. For literal expressions that we have, we are trying to calculate the entropy. It's a known function that we can find in the references, and if its entropy is higher than certain value, it could be configurable on your side, like it could be lower if you ready to deal with more false positives like this one or other secrets, or it could be higher to have less false positives. Okay, so we can define secrets and we can find them based on the entropy. It's a random value. What I'd like to do next, if it's enabled in our security now profile, now it's time to analyze for the whole project. Let's do this. We are finding results, not for this one. Okay, so we have some false positives, but we also have results in our hard-coded. Let's wait for a bit, it's still running. Okay, I know what's the problem. Let's stop it and go to the settings again. And here we should, okay. One more time. We run analyze, we inspect code, we choose demo security. Now it's the correct one. So we have our secrets in a hard-coded secrets, but there are other places where we defined and we can find secrets in this vulnerable application. So it's not only our code, but there are also false positives because we are not focusing on patterns. Okay, so the idea is that you can write your own inspections much easier than you thought before because you have these flexible inspections. And this flexible inspection, according to the name, they're flexible. It's would help you to find everything that you can find through this PSI structure for the test files. Okay, what's next? Here in a demo, there's a, let's try to create another one, another file. It will be called demo servlet, I think. It's extended from the Jakarta HTTP servlet. Yeah. Not this one, it should be Jakarta. Yes. If you're not aware about the servlets, don't worry. It's old technology, but it's good for simple examples. And get and that takes a user input from a field message and reflects back to the user. Okay. The idea is to generate something that will be hopefully looks like cross-site scripting, reflexive exercise that we already discussed. So here we have user input in a parameter message, and then we are trying to send it back inside the response. But this structure is a bit more complicated that I would like to have for the beginning. Let's do it in a different way. We will get right over here and reflect our message without anything. It's just for the short demo because, well, we are running out of time. So here, the first thing, you should find the user input itself. It's, again, our structure search and replace. And we have some meta variables here. We'll call this one user input, and we search for the user input in particular. We need this one to use as a reference later. For the request, it's only one type that we're interested. It's only HTTP servlet request. Let's do this and set a type modifier for this. For the method call, it could be something like a general getter, and there could be something like a simple regular expression like this one. And here it also could be anything because it could be different name, but it's still user input, right? So we will use it and we should save it as a in our IDE to reference later, and it will be called demo again, user input in servlet. Okay, so we have our user input, right? We can find it. It is here and in many other places. But it's not an issue itself. It's only an issue when it's referenced back to user without a proper sanitization escaping. Then we are starting to trust strangers, right? So here, the next step is to select this one, copy again, structure search and replace template. We'll write a button to get this code. For the response, again, it's a meta variable, and we'll use type. Here, it will be something like this one. For the message, and it's an important place to show the magic, it will be called user input. And we should use a reference that will be called, that's called demo user input in servlet. And yeah, it will be complete match, and we'll save it as inspection. It will be called reflected success. Okay, let's close it and take a look at the result. Well, it's kind of work. And if you want to catch other places like this structure and other structures, like if you have something like a prefix, then it won't work. And there are many, many cases that should be added and written. But if you take a look at the settings for the structural search inspection, where it is here, you can add many patterns here, like I have one prepared with many, many patterns. Let's enable it instead of our custom simple thing. Well, yeah, I think I removed previously created dependencies. Okay. So the idea is that you can add many patterns, and if you have many cases, you should cover all of them. Well, it could be difficult and tedious, and why should you do this? Because you just need to track user input to the unsafe place, and we have a better inspection for this. Let's prepare a simple code. I won't spend your time, and don't write it now during the demo. Okay, and I just removed these annotations for the beginning. Oh, okay. So it's a simple example where we have something like a source from the method called source, and when it's reaches sync, don't think we need to pass here for the first example. We'll just do it directly. It's a sync, and there's a source here. Yeah, and we have an inspection that is called non-safe string is passed to a safe method, and we can enable it. By default, it's working on annotations, and there are two annotations that we need, tainted and untainted. They are from this framework. We'll use it now if I have an input. I hope that I have this input. Okay. But don't worry, I think I have it somewhere in a shelf. Okay, let's unshow it. Okay, so now I have it. Let's navigate to the code, refresh our dependencies, close this one, and navigate back to our demo servlet. Okay, so now I have this tainted, and I also need untainted annotation. So let's annotate source and let's annotate our sync. Okay, so you just need to annotate source and sync, and it will be tracked for you. So like unsafe sync is used as a safe parameter. Even if you add something like a path-through method, where you are not changing anything, you're just using the parameter, adding it somewhere like a string builder, other places, you still will be tracked, and you still can find issues in your code, like this one, unsafe string is used as a safe parameter. But there's a problem with our case. It's not our own code, right? And it's a code from a library, and we cannot add annotations to the code to the library. So what's then? How can we use our inspection? We'll use a reference and navigate to the inspection here. And there are a lot of settings here. Maybe it's too small, but I'll try to explain it to you. There's something it's called tainted methods, and tainted methods are a place where everything is untrusted. We'll find our request, and the method is called, let's use something like any get with a regular expression. And for untainted parameter, we'll use this one. Yeah, it's not that accurate as it could be. It could be much more accurate if you configure it properly, but let's do it simple for the demo. Okay, let's add it for untainted parameters here. we need class edit, and we need method name, and we need something like index. Yeah, it should start from 0. Okay, so you see that even if it's a much more complicated structure, and it will be more difficult to catch issue with the structure search in place, you can do it with a simple taint analysis. This taint analysis is, I called it simple because even that it's a thing that's called like complexity or like analysis depth inside the method. Now it's like 5, but it has limitations and it's only inside one file and it cannot track really complex taint flows. Okay, but if you don't want to configure your inspections and you just like to check your code for pre-configured sources and things and find the vulnerabilities, what you can do. The next available thing to you is called our security analysis. Okay, I don't know why it's not enabled, but well, inside it's configured for cross-site scripting, command injection, SQL injection, and path reversal. And you don't need to configure your own sources and things. But if you would like to have your own sources and things, you also have this option inside inspections. You could configure new custom inspection, and there will be new taint configuration. I will call this something like a custom analysis, and I will add pre-configured places like these two. I should import it. Okay, and compile it. So you can define your own sources and you define your own things, and it will be work for the taint analysis. Okay, maybe I should just start it, and it will work. Just give me a second. If it's not working, we'll go for the, so it's in tools, security analysis. Okay. Okay. So it's here. You can configure sources and things, and it will work, I hope. So the next step is like a final part of the presentation. If you like to combine everything together and have your security inspections working for you, not just inside your IDE, but maybe in your CI/CD pipeline. We have a tool, it's called Kadana, and you also can try it locally. Let's start with a pre-configured set of settings. I think it will be something like, I have it somewhere in a shelf, I think. Yeah, I will reuse this one. And let's check how it looks like. So we'll use empty name here. We'll uncomment some inspections, maybe not these two. And we'll discuss list 3 bit later. So let's and analyze the project. It will take a bit. So here it's loader for this. Yeah, and for the Kadana, you have pre-configured GitHub Actions. You can easily enable it for your repository. It's also a Kadana cloud where you can see the results on a nice web UI, and you can control your issues. It's not just about security issues; it's about all kind of quality issues, and you can, as I showed, write your own inspections and find security vulnerabilities, like I'm focusing to with my working life. But it's also possible to just check code quality, as many software developers do and can. Yeah, so taint analysis is working here. Thanks. And we have also vulnerable dependency. So inside the code, this part of the code, you can find. Let's take a look at something from taint analysis. Yeah, this one, it's working. And inside the IDE, it is working this way. It's showing it's our simple taint analysis. Let's find something more complicated. Yeah, so here you have a tenant analysis flow. You find issues, and if you'd like to see how it looks like inside the Cardano, or it will look inside the Cardano cloud. It looks like this. You have your issues. You can analyze them. You can find the category like security. You can choose inspection. Let's focus on something like, I don't know, SQL inspection injection. You can see the whole data analysis flow from the source to the thing, and all this like this untrusted input, and it's landing to the query that is going to the statement that is executed on your database, and it shows problem. Basically, that's only one part that I'd like to highlight really quick. It's also a nice tab called Vulnerable Dependency. And here you can find vulnerabilities in your dependencies as well. And third-party vulnerability libraries could be vulnerable, right? So it's also highlighted in your editor. It shows your CVE. It's also possible to, if you enable, disable this analysis, I think, because it's kind of overlaps. You can okay, more information about the package. Usually there is also a quick fix to update it to a safe version. You can also find usages in your code where this library is using and how it's affecting other components of your code. So yeah, basic configuration, it looks like this. You have tainted methods and you have untainted parameters in your inspection configuration. This inspection, simple taint analysis and structural search are available in all editor editions of IDE on the one, so it's not required ultimate subscription. And for Cardano, you should take a look on the pricing for using Cardano and Cardano security analysis in IDE. And that's all. Thank you. Maybe I still have some time for questions. I don't know.
Thank you so much. It was very interesting. I mean, you showed us so many features of idea no one ever saw, like structural search and replace, which is probably a huge topic by itself. I mean,
Yeah.
you probably can give a talk on this one small dialog window, and the whole taint analysis implemented in roughly 50 lines of code, I guess, looks very, very impressive. We actually have one question right now. Yeah, we already have two.
Okay.
First of them, how can we get developers to see security as an integral part of their jobs rather than an afterthought?
Well, I think it's my vision. It's not necessarily widespread, but I think it's a thing for the several years. It's like a shifting left. And my understanding is when your IDE or your tool is showing you that you have a problem right inside your editor when you're developing a code, it's much easier and it's like a professional approach for developers to fix it right away. Otherwise, for example, if I am developing a tool and I see that I edit a library and it's vulnerable, why shouldn't I think about a safe version of this library, right? Or if I see a highlighting in my favorite IDE and I think, well, it is a SQL injection. Well, it's a terrible issue. I should fix it inside the IDE. But I know that for some developers, it's much more difficult to fix issues afterwards when it's already in a live product and its developing is done. But then you're thinking, well, if I will fix this, how it will affect the product itself? How many hours quality assurance colleagues will spend to find that the system is working the same way? So I think that shifting left will help and should help software developers to prevent some decent amount of issues. I'll answer in this way. And if it's IDE and it's development environment for our software developers, then it's an integral part of their job to fix these highlightings to make their code clean, and secure.
So you're saying that developers shouldn't change their mindset on their own. It should be the tooling which helps them.
Well, it's from the both sides. I think that from the tooling we can shift it. We can show problems, and if there's a problem, I'm sure that developers, I myself, and I'm working and see a highlighting an IDE. I'm thinking, well, maybe I can fix it. I really like to see this nice green check mark on the editor.
Beautiful.
My
Thank you so
approach.
much. I have one more question, but if you have time, I will probably ask it after we all have done talking, and I'll probably give
Sure.
a thank you so much. And removing you from the stage for some time and inviting in my dear friend and colleague, Kat. Hey, how are you?
Hi, Pasha. I'm fine, and you? How are you?
I'm still alive. It's what I always answer. It's probably I just don't keep my expectations too high.
Oh, you are very realistic, and I think that's good.
So, did you have a chance to listen to our previous speakers?
Oh yes, I of course I listened to Patrick and to Grigori, and I think I have something valuable to add to both of their talks to make the picture of secure development deployment more complete.
If you think so, then let's just jump to it. But could you please share your screen? I don't see
Yes,
it
of course.
shared right now.
Yeah, just a sec. Um, right. Um, just a sec. Yes, it
No
is.
worries, no worries.
Okay.
Let's try. Yeah, it's there.
Yeah,
Beautiful.
it's there, right?
Then I'm giving stage to you, and I'm slowly disappearing.
Awesome. Awesome. Well, I mean, not awesome. Masha, I'm going to miss you, but for 25 minutes, we'll have to do with me. All right, friends. Hello, everyone. Thank you for joining us today, and thank you to everyone who stayed with us through this hour and up to my talk. I hope I will manage to tell you something interesting, right? Something that you may like. And today we're talking about hardened container images and how they can make your Java services bulletproof. So, for those of you who follow our CyberJar channel, you know me. For those of you who don't, well, I don't really understand why you still don't. You really should hit this subscribe button right now. But anyway, my name is Catherine Edelweiss. I'm a developer advocate at Bellsoft, and I'm mainly focused on helping teams build secure and more performant cloud-native applications based on the JVM ecosystem tooling. I'm also a tech writer, co-host of the CyberJar YouTube channel, and I like to call myself unorthodox by design because I'm rarely satisfied with the status quo, and I'm trying to find a solution that fits my use case or the use case of the developer or customer more, right? Even if it's not an established practice. But who are we actually as Bellsoft to talk about security, right? Because the topic of our talk today is security. Well, we are members of OpenGDK Vulnerability Group, so it means that we have access to all the recent patches, and we are also able to commit patches and fixes upstream, and we do that regularly. We have in-house JDK and Linux expert, so who provide the patching, and we also develop and support hardened container images. But wait a second here. What is that? What are hardened container images? Is it just a new buzzword? Well, let's take a few steps back here. We can't really start the story from the middle, right? Right. And my story, well, it may not start as a beautiful fairy tale. We live in a very, very dangerous world, right? We are surrounded by malicious actors who want to do us harm to our beautiful applications and to our projects. And in this world, the container image that you deploy to the cloud should be a safe city for your application. And yet, somehow, you might be dealing with the delayed deployments, with the revenue loss, the operational burden placed on the team, and in compliance with the regulations. And all of that, why? Well, because actually, the typical container image is not a safe place to live in. It has lots of smuggler tunnels, which is the package manager, the unnecessary components in the base image that you are using. All of them represent a potential exploitable path for the attackers. Also, there is the thick fog covering the streets of the city. So it means that you actually don't know where the image comes from, where comes the foundation where the city is built on. The base image, where does it come from? Who is responsible for updating it? Is there a defined update cycle? You don't know anything about that. And of course, in the fog, you might be seeing phantoms or regular good citizens or bad guys, and you don't know that. So these phantoms, as I call them, these are the vulnerabilities or security weaknesses that can be exploited. And there can be hundreds of vulnerabilities in the base image. And for each of them, you need a patch. So the patch is a way to eliminate a specific vulnerability. In this thick fog, you don't actually know what is a phantom, just a mirage, or what is a really, really dangerous, well, so to say, monster or a person who is just waiting to give a hand, a helping hand to the attackers lurking outside the city. Well, all of that is not some kind of a dystopian fantasy, but actually a reality of modern cloud deployments. And every year, there are more and more vulnerabilities discovered. In 2024, 39%, almost 40% more vulnerabilities were discovered than in the previous year. And in an average container image, we can find about 600 vulnerabilities. Well, what about Java services? Specifically, Java services don't have it well. 44% of Java services contain known exploited vulnerabilities. All right, well, and then there's open source. We all love open source. I love open source. But the problem is that more than 90% of projects contain open source components which were not updated after the CVEs were found and patched. Well, this is the city your application lives in. What do you do if your app lives in such a city? Well, there are three solutions. There are always several solutions, right, to the problem. Attack, stay, or leave. Let me just dwell on them for a couple of minutes. So, first, you can try, theoretically, hypothetically, to attack the outsiders first. Well, but that sounds weird, right? So for example, I do boxing, but I don't go around some dark corners of the city looking for thugs and looking for ways to beat them up, right? So you even if you had the chance to catch and imprison the malicious actor, the hacker, you wouldn't go around looking for trouble, right? So that's not a really viable solution. Okay, you can stay and defend the old order. You don't have to change everything, and many teams do that. They react to patches, so they introduce patches reactively, right, when the necessity emerges, and they react to security incidents, right? So there is no proactive CVE management process. Yes, of course, you can try patch all these vulnerabilities on your own. Of course, it will place a burden on your team, but you can do that. Still, why should you solve the issues in the code that you didn't write? And the base image is not something that you wrote, right? You took it somewhere, right? But it's not your code. Why should you deal with these issues? Well, the third solution is to leave actually and move someplace, let's call it the arcology, or a more safe, secure place for your application to live in. It means that you will have to build a new container image from bottom up, and you have to find a new foundation, a solid foundation, a clean foundation for the city. Of course, that may sound terrifying. I mean, there might be so many questions. Where do you find a reliable base image? How do you choose a reliable base image? do you need to refactor everything? Is it going to be compatible with your application? And will it actually solve the problems that you're experiencing now, or will it introduce even more problems? Well, of course, you don't know that. But in fact, it is not so terrifying. Because do you remember we started this talk with the hardened container images? Well, we came to the point in our story where it's time to them to enter the stage. So the hardened container images or hardened base images might be called the new container security standard. They rest on several pillars. They contain low to zero CVEs, so they are clean from the very start. And when you use this base image, hardened base image, your container image is also safer from the very start, from the very beginning. There's no package manager. There is only the limited choice of components required for your application to run in production. That's why there are different images for the Java application, for example, or for the Python application. Right? So it has to be minimalistic. This way, the attack surface is reduced. And this component set that you have in the hardened base image is immutable. It means that you can't add new packages there. So this way, there's no chance of tampering with the container at runtime. And this hardened base image with a limited choice of components and with the set of components has a list, the software bill of components. This is a list of all the components included into the base image with their respective versions, with their names. So think of it as the list of the ingredients that are predefined for creating some dish, maybe, right? Or in this case, the foundation for the application. So it means when this base image comes with an SBOM and when it is signed by the vendor, you know what is in this image. You can say for sure, we know what is running in our production and we can prove it. So you know it's in the image, you know who made it, right? And you can prove it. This facilitates the audits and the compliance with the federal standards that demand actually having an SBOM, the provenance data, and a very clear CVE management process. And the image, which is clean from the very beginning, stays clean because the vendor performs the continuous patching of the image. So your container image always stays safe, right? And that's what we do. We provide the hardened based images. So, and let me just tell you a couple words about them. Our base images are based on Alpaquita Linux. We created Alpaquita Linux several years ago when we saw the demand for a minimalistic Linux distribution like Alpine, but more secure, more flexible, right? Not only with the muscle library, but also with the glibc library and more performant. So Alpaquita Linux is minimalistic, just like Alpine, and hardened Alpaquita Linux is even smaller. It has LTS releases and two flavors with optimized muscle and glibc. So you can choose the one that fits your application. Also, we provide a variety of images for various runtimes and on various platforms. These images are free, so you can go to Docker Hub, to GitHub Container Registry, Microsoft Container Registry, Google Container Registry, and Amazon Container Registry, and select the image for your application and, for your specific workload. And if, by the way, you hear any farting noises, this is my very cute dog sitting right next to me and watching me closely. If we are lucky, it comes by and says hello. Right, so coming back to hardened base images. The solution that we provide is not only about patching vulnerabilities, is about providing you with a comprehensive solution from one vendor. Right? So we provide the security for the runtime, for the operating system, and for the container. this is our team that provides all these things for you. You don't have to work with different vendors for getting the security patches for the OS, for the runtime, for anything else, right? You have everything 3 in 1, so to say. And we also have the ability to introduce patches ourselves. We are not just pulling patches upstream from upstream. We can create our own patches, right? And you can use that as well to your advantage. So in other words, our team can handle the security of your base image, and your team is free to focus on what really matters, on your application security, on your application performance, on your application. Well, that is all very well, but the data speaks much louder than words, and let's have a look. You can go to our website. Here you can see the link at the bottom, the Bellsoft Hardened Images page, and there you will see the comparative table for the Bellsoft container hardened container images and other standard container images, and you can compare the number of CVEs in real time. So here we can see the comparison between Liberica runtime container with Liberica JDK, JRE, and Eclipse Tamarind. And here we can see that there are 33 fewer vulnerabilities in a hardened Liberica runtime container. Okay, let's take, for example, Python. Here we have 43 fewer vulnerabilities. So yes, the data speaks for itself. Of course, you can browse other images and see what kind of goodies you can get. Right, and here comes the most exciting part. How do you actually migrate to a hardened image? Well, as I already mentioned, our hardened images are free to use. So if you don't need an SLA, you can go right now to Docker Hub or to another container registry that you use, grab an image, it is tagged with the word hardened, and use it in your production, and that's it. So let's look at an example. Here we have a Docker file for the Java application. You might be using build packs, but in the case of build packs, you already have security integrated. So build packs create the NSBOM by default, and the Linux distribution, underlying Linux distribution, is also immutable. But if you're using Docker files, like this one, you can take advantage of hardened images. So here we have the Docker file for a Java application. It uses the OpenJDK image as a builder. It compiles the application and simply runs it. So, and after that, if you want to migrate to a hardened base image, you need to use a multi-stage builds. So at the first stage, you build the application, and then you transfer the jar file into the fresh base image. So here it's going to be much smaller because it's not going to contain the compiler or any other unnecessary tools for running the application. Again, as I already mentioned, the component set is immutable, so you don't really need to add any packages here, or you can't add any packages here. So you do everything at the first stage, and then at the final stage, you simply run your application. So here we're using the hardened Liberica runtime container, JDK, the first stage with glibc, but you can use Muscle if you can. We are packaging the application, and then we are using the hardened Liberica runtime container with JRE, and we transfer our jar file into it and simply run it. So that's it. But if you are already using multi-stage builds, the question of migrating to a hardened base is just changing the from line in your Docker file, and that's it. Also, it is important to note that pinning the images by digest is recommended for build reproducibility, right? Because tags can drift, but digest don't drift. So you pin them by digest, and then you add the comment, what kind of version you use. But that's just a useful piece of advice. And then that's it. Already you have a very safe place for your application to live. It's buzzing with activity. There's no fork. Everything's clear. So there's no package manager, no smuggler tunnels, right? You know what components are used in the image. There are almost no CVEs, and all the known vulnerabilities are patched by the vendor. And if there's no patch upstream, we can make one for you. Okay, right. What's next? You migrated to a hardened base. Brilliant. You already solved most of your problems, and then you just work on that. So you continue strengthening and building the city on this solid foundation. Right. So you verify the signature of the base image that you pull with the cosine. You can also do that in CI/CD. You should set up the monitoring for the updates, because when the vendor updates the base image, it's not updated automatically in your production, so you have to do that. In this case, you have to set up the monitoring for the updates. Your base is solid, and then you follow container security practices, and you can focus on the application security. You can deal with the application dependencies, you can deal with application code, right? And the base image, the problem of the base image is already not your problem anymore. It's not a problem, right? And to sum up, hardened images integrate very well into DevSecOps practices because they enable you to establish a clear CVE management process. You can have provenance data with an SBOM, with digital signatures for compliance and for audits. And you can, in this case, shift the security left without slowing down the deployments, without postponing the releases, and without placing the additional operational burden on your team. And that is, I think, basically everything that I wanted to tell you. Thank you very much for your attention. I will be very happy to hear your questions if you have any and answer your questions. Otherwise, you can find me on social networks like Blue Sky X. You can go to our website, look at the hardened container images, read a little bit more about them. And yeah, that's basically it. Pasha, I can't hear you.
Sorry.
Yeah.
Thank you so much. Thank you so much for your talk. It was exciting indeed. We have at least one interesting question in our chat section. How can I get SBOMs for the hardened images?
Well, the hardened images already include SBOMs, so when you pull the hardened image, it also already comes with an SBOM.
I have another question from myself. Can I, like, when I am building my Docker file on top of hardened images, as far as I know, there are no build packs on top of hardened images just yet, right?
Yet no. Mm-mm.
Okay, so if I'm building my Docker file on top of hardened images, can I put my own tools in there? For example, there is no curl in default hardened images, as far as I know. Can I copy it to a hardened image?
That's an interesting question, Pasha. So thank you. I know that you can potentially add files to your container image from the outside. But then again, if you're adding curl, it means that you're already making your image mutable, right? It's not immutable anymore because you can pull packages with the curl that you added. And I don't think that's a very good practice.
I would say that images are mutable anyways, because, well, I mean, you can't mutate the previous layers. But I got your point. The idea is we will increase our attack surface, right? By adding curl. Okay.
Of course.
Which is potentially risky. I will add Patrick and Grigory here in a second. Hey, thank you for keeping up with us. Folks, we had at least one question in the comment section which might be relevant to all of you and maybe to all of us. How is security in the vibe coding era? Like, did anything change? Should we care more or less about security? I should probably moderate it a little bit. I guess Grigory has a strong opinion.
Yeah, of course. Pasha, thank you for asking me. Yeah, it's during the validation, I generated a code using our AI assistant, and it's not a fault of a tool; it's fault of or okay, let's case like a lot of fault, but maybe a feature of a tool that's beneath the AI assistant in our IDE. It's all these large language models that are generating code for you. Well, sometimes it generates a safe code, sometimes it's not. If you have more code during live coding session, and usually you have more code because I tried to build some application purely by vibe coding, and it's generates tons of code. It's not large. Usually with your software development speed, you have much more code, and you have more vulnerabilities. Maybe it's the same level like for average developer, but if you have more code and you have more vulnerabilities. So my opinion that for the vibe coding, you should have something accompanied to the tools or inside the tool. They will check the code like we did it before. You have software developers, you have quality assurance specialists, you have security specialists, right? So if there will be a review from software developers and there will be land somewhere in our team, please review our code and we'll do it. You should apply a similar approach, in my opinion, for AI vibe coding. There should be different agents. One agent is writing code, second is checking quality, third is checking security, etc. That's my opinion.
Okay, I like it. Does JetBrains work on something like security coding agent?
Well, we are thinking about it.
But what if your data from your agent is outdated? I mean, there is so much like documentation out there, like also in the models, which is just outdated. And if you search the internet, if you search Stack Overflow, you might copy the wrong thing. Like, for example, like your wrong Docker file, for example. And how would you know? I think it's exactly the same as before. We need to add some measures, as you said, basically like some checking. That's very important. But we just cannot delegate everything to an agent. I think there is still like some special knowledge needed as well, because like you need someone who needs to be able to judge what the thing is doing, basically like the human in the loop thingy, right?
I kind of agree with you. We are trying to shift everything to the left, and at this point, we kind of shifted the coding to the left from us, and now we are not always in the loop. Catherine, do you also have an opinion?
Well, yes, of course. What I think is that the security monitoring is even more critical at the time of the wipe coding, because you are less responsible. Developers are less responsible for the code they generate and for the base images they use. The development process is accelerated, right? Because you have the AI tools and you are demanded to do more work because you have additional auxiliary tools and you don't actually have time to check that, or you don't want to check what you're generating as long as it passes the test. So yeah, security I think is even more crucial right now, talking
But
security.
you just said actually like developers are less responsible. I don't think so. We produce more code, but we are still responsible, and we should be actually what is produced. Doesn't matter like how it's produced, and therefore actually there should be like rules in place. I mean, of course, there will be always like humans responsible for what you ship. I think that should be. It's not like developers are less responsible.
Well, yes, you're right. What I meant is that they generate code more than they write code, maybe
course.
these times, right?
Yeah.
And so in this case, it's maybe harder for them to set up also the security monitoring, or they don't want to do that. That's a different thing. Yeah, they're not less responsible, right? But the sheer amount of code that they have to write is, well, overflowing.
What do you think, folks? Like, there are multiple companies, for example, Amazon, who say, hey, right now AI ships, I don't know, 70% of our code or 50% of our code. I'm almost sure there are security issues with this code. Do you think people will be able to blame AI for making security vulnerabilities, or will they try to blame, I don't know, developers who use the AI tools?
But what do you mean, Pasha, by blaming? Like, if there
Like
is something
actual
like a
blame.
security
I mean,
incident, they'll say, well, it's not our responsibility. The responsibility of AI model that generate this code. It's security
yeah.
admin
So
do this.
what I mean by blame is like my manager will come to whom? To me or to my AI assistant to ask me, Pasha, how did it happen that we have this huge PII leak?
Well, it's still something like a two threads or two things. Like if it's internal discussion inside the company, well, I think people are already blaming AI for bugs, for
Do
problems. It's
they?
already
Oh
there.
wow.
Well, I think sometimes it might happen, but if it's an external thing, I think it's really bad answer to your users, to your customers, to say, well, we generated this code and it was vulnerable because it was generated by AI. It's unprofessional, 100%.
Patrick, what do you think? Do people come to you and ask you, how did you generate this code and why is it so wrong? I'm joking, of course. Obviously, your code is perfect.
Depends on your use case. Let's assume it's a self-driving car. So yeah. So can you blame the AI? I don't think so.
Yeah, like this is my way of thinking too, Kat. Do you agree?
Oh yeah, totally. Well, of course you can hypothetically blame the AI, but what will you do with the AI? I mean, you can't punish it. You can't
Slap it.
slap it. Yeah, right. Yeah, that's not possible. There's always has to be the person, actually.
Yeah. So, and this is my essentially answer in the form of question to your statement about less responsibility. Actually, probably developers have even more responsibility right now, because if they generate something, they're responsible not only for the code they wrote themselves, but also for the code they generated or they were helped with. It's like blind copying snippets from, I don't know, Stack Overflow. It will create issues. The same with AI tools. And yeah, we are crazy. Like the level of responsibility is actually skyrocketing right now, in my opinion. Folks, I think we all are tired. It's almost 2 hours. It's far longer than we expected, because your content is just so amazing. I mean, I couldn't stop you, and I have so many more questions. But looking at the numbers, probably our audience is slightly tired. Thank you so much. Thank you for spending time with me. Thank you for sharing your knowledge. Hopefully, we'll see you one of the next time. Not the next time, it will be boring. One of the next times. And on the conferences. Dear viewers, if you want to see these amazing people in real life, please go to the actual conferences and you will be able to ask all the questions you want. And this is the biggest premium we can have with live conferences in opposition to these online ones. Thank you so much. Take care.
Thank you.
Thank you. Bye bye.
Bye.